Okay. So you do not need to write every single word of this down. Just get the general idea. Mutations can occur at any point. So you could have cells that mutated to be able to evade the immune system, but they never hyperproliferate. Or they do, but they never get that mutation for proteases, so they stay within that first layer. Or you could have them get all the mutations, and then like as soon as they break through the basement layer, they're off to the races. So that's why sometimes people have a really fast progression, or sometimes it's very slow. And it could also depend on the organ that's being affected, the cells that are in those tissues. Secondly, size does not necessarily mean that it's a more severe form of cancer. I have two examples here. This is a large benign tumor that can occur in your salivary glands. And it will just grow and grow and grow and grow, but it doesn't typically go past the basement membrane. So you can have a very large swelling in your kind of jaw, neck area, cheek, but it's not cancerous because it stays benign. Whereas a melanoma, this is a really dangerous form of skin cancer, and it can start as a very small mole and can quickly progress to like stages 3 or 4. So size doesn't dictate severity, and the mutations can occur at any point. They don't have to occur in order. This is just the order of progression usually. Yeah?
If you have like a large benign tumor, do they usually take it out, like surgically remove it?
I think they should, yeah. Usually this would probably be a pretty easy one to remove. But if it gets this big, you're taking the whole gland out with it. So you're just losing some saliva production on that side. Okay, we understand these concepts? Yeah. I mean, that's if you are privileged enough to have healthcare, have access, have, the ability to go to a doctor. So it all depends. Okay? So let's do a real quick mini look at how a cell progresses and then how a cancerous cell basically can go backwards. If we look at differentiation, we have something called a multipotent cell. This is just like a little step down from a stem cell. They look the most kind of round and undifferentiated. Then they can divide to form progenitor cells. Typically a progenitor cell is destined to be one of 2 different types of cells. So we're showing a little bit more differentiation, and this is what we would call like an immature cell. So a fibroblast is a type of progenitor cell. Then those cells will further differentiate to make our terminally differentiated cells. Typically, these terminally differentiated cells no longer divide. They perform their function and then they die. So notice, this is just, I chose blood as an example, but notice how the shape changes as we become more mature, more differentiated. And shape dictates function. So as long as the cell is maintaining its differentiated shape, it should be able to perform its function. Yeah, so this is just general cell progression. So what we're going to see happen is cancerous cells can start to take on the shapes of its previous versions, which means it's no longer performing its differentiated function, and it can kind of differentiate into other things. So that's the danger. So we call this the grade of the cell. So not only are we looking at where those cells are they still in that original layer? Did they invade the stroma? But we're also looking at the shape and the size of the cell. And we call this the grade of the cell. So this can tell us, again, more about severity. Like maybe you only have stage 0 or 1. We only see it in its original thing. But when we look at the cells, they're really misshapen. That's a warning sign that they're potentially going to be more cancerous if they get out of that basement membrane. So if we have lower grades, that means that we're still in our differentiated shape. We should be able to still perform our function. Higher grade cells lack this. They're basically look like they're going backwards in the differentiation path. So they're going to look more like a multipotent stem cell. And you'll also notice, like if we look at these patterns, instead of seeing our nice like line of cells, not only does the shape change, but how they kind of stack starts to change. It really looks mutated. So it's no longer, in those nice lines. Sometimes, depending on the tissue we're looking at, this scale can be from 1 to 5 or 1 to 3. It kind of all depends on, again, what we're looking at. Yeah?
Can you have cancer where the stem cells, like in the stem cells?
So once you are a fully formed embryo, you really no longer have omnipotent stem cells. You only have multipotent stem cells. So these can be cancerous. So like leukemia is a cancer of those cells, of the bone marrow. And they manifest as producing these immature white blood cells. Yeah.
So as like a baby, right? Could they have cancer as well, or
I don't know, because most of the time, if there's genetic issues, it miscarries. So that could be a sign of like embryonic cancer almost. Yeah. Amelia.
So with the grades of the cells, is it like you only use the grade for cancer cells, so like all other cell types of type 1?
Yeah, they should be. Yes, exactly. The terminally differentiated is like our control. That's what we compare it to, and that is 1. That's always going to be your lowest number. Yeah. Here's just another example, same kind of thing, and it's drawn. So in this case, our scale goes from 1 to 4. So you can see in grade 1, we still can see our nice, like simple cube shapes in those round. And then by stage for grade 3, they've totally lost their shape. They've lost the way that they're stacked next to each other. So that's another big thing that we take into account, is the grade of the cell. So let's go back to our patient. I've circled, I think maybe some of you noticed, I've circled the 3 areas where we most closely resemble what we should be. So take a moment and after everything we've discussed, try to figure out now what stage we could possibly be in and what organ and tissue type is being affected. So what epithelia and maybe what organ this is.